Hi, welcome. This is hardware overview in embedded systems provided by GearTech, and that's my email if you would like to have some contact with me. So we're going to discuss a few basic concepts, big picture concepts that aren't that technical stuff. So the first point is to understand the big picture. And what we mean with understanding the big picture is that you just need to understand the general operation of the system. Such as the board's main function and what's the input and output are. And the point is, whenever you receive a new board, you should take some time to read the main documentation provided with it. And there are two, you need to read the documents and figure out some basic questions, answer some basic questions, and as an example might be that what's the overall purpose of the board is something related with rendering images, audio processing, I don't know. The second one is how does data flow through it, and this might be easy to answer if you have a diagram of an image of all the board. So as I said, define block diagram of your hardware application. And I think that I don't have a diagram for it. Yeah. Okay. So the next one is the hardware basics, and we have something that is called schematics. That it's all the. I think that I have the image there. Yeah, this is kind of a schematic of the connection that microcontroller has with several. This is a bus, several components. This is a resistor, what have you, and what it does is the schematic is a drawing comprised of standardized symbols to represent all of the circuit's components and connections. That's the concept of schematic. And you also would like to have some data sheets of all the major components of your board, so you can seek out the schematic and see all the components you have in the board and find and download all the data sheet. So it's a good idea to look for any errata documents for all the devices. These documents will give you a heads up of any issue regarding the way of the device operates. And there are updates in the components. You might have a data sheet that has obsolete components, so you might have some problems. Periodically check for dates of the components, and that's will save you to the frustration of chasing a problem that was fixed in updated data sheet. So schematics, we were talking about schematics, and this is a basic schematic that it has a reference designator, pin numbers, active, log. We're going to discuss that. So a reference designator is a combination of letters, numbers, or both, which are used to identify the components of a schematic. This is a reference designator, RX1, CPU reset, they are the reference designator. And we also, along with the reference designator, we also have the values and the pin numbers of the components, and they are like these ones. You have a microcontroller and you have a pin in that, so you are connecting components in those pins. Then we have the concept of active low, where you are setting or saying that this is active. This is active if the signal is active. It activates the functionality of that pin, and it's called active low when you activate with a logic level of 0, and whereas logic level of 1 will deactivate the function. So there are some junctions here. You can see that it says that no connection between two necks, but this is a junction, is a point in the connection between two wires, or you may also call it a test point. No, it's not a point, it's just a junction, right? So components type, we have different components type, and to know the model of the component if it's necessary. 6, the data bus. This is a data bus. It is a thicker line leveled, and you can join a lot of data and express it like macros or a chunk of memory of data. So the second step is to examine the landscape. So examining the landscape is who is connected to the process. You would like to imagine that you are the processor, and you need to figure out which components are connected with you. So the processor has a lot of compatriots. There are other pieces of hardware in the board, and there are two basic types of hardware which the processor is connected. That is the memories and the peripherals. So memories are the storage and retrieval of data and code. The peripherals are specialized for hardware of devices that are outside of the board. In the outside board, or performs a specific hardware function. Right. So yeah, I think that's it. So memory map, we have what is called memory map, and the first thing we have two different buses, is the address bus and the data bus. And the address bus, there is the processor, and to reach or do I don't know, maybe a task or any instruction that it might want to develop or to process, is that the address bus, you need to go to the address of certain device or certain part of the memory. So after that, you say, okay, from where the processor takes the data, it might be in the RAM, it might be in the ROM, it might be somewhere else. And when you know the address and you took the data of that address, the specific data, this data will return to the processor, and you might ask the question of which data the processor would take. So you know, the memory is located in the processor memory space, and the processor communicates in two sets of electrical wires called the address and the address bus and the data bus. And as I say, all this stuff between the address bus and the data bus is made by the address decoder. Is some concept that is called address decoders. And an address decoder interprets the upper address of the bits of the address bus and selects the appropriate memory or peripheral chip. Then the data is transferred over the data bus. It's sending a message, returning the data. Okay. So we also have the concept of control bus. Any control signer for reading and writing to various devices in the processor's memory space are commonly referred as a control bus. As control bus determines if you're going to read or write or select a certain chip. And this thing that is the chip selection is when you have it is set to its active level when the address of a particular device falls within the device address range. So you might have certain space between here 000 in hexadecimal 4000. So the chip select signer will be triggered if you have, I don't know, maybe 10 hexadecimal, that it's in the within the range of 0 and 4000. So that's kind of the point. And something that I would like to discuss also is the read and write signals, and they are set to their active levels by the processor based on the type of the memory transaction. It depends on the transaction, the memory, how to it determines the way that you read and the write. And there is also the timing diagrams. So timing diagrams is the base part of the timing requirements. Our timing requirements detail the minimum and maximum acceptable times for all the various signals that we might have, like this one. The timing diagrams represents the timing relationship between the various signals for a given operation. So we have the clock that is infinite, and we have data bus, and some simple signals that we have. So let's continue to the second part of this. Hi, now we are going to continue with the presentation of the hardware and embedded systems. And in this slide, we're going to talk about the timing diagrams. The first signal here is the clock. And the clock is very important because it is a square wave that sequences all operation of the processor. And in the diagram is the first signal in the top. It's the square wave. In the next line is the buses are typically stable, meaning that the bus can contain a valid address. And when a bus is single line, like this part, it goes to tree state. That means that the pin, one of the pins has no relevance, is unreachable, or has high impedance. The two lines means in this part, it means that the bus has real information in it. The CS chip selector is active by a 0. That's the way that it has a slide. And in this case, so in the diagram we have a read-only operation because the write pin is set in 1, and we only have read operation that takes a part of the bus A and the bus D. The next slide is there are some bases to use software development in the embedded systems. The first one is to draw out tables showing the address memory for each memory device and peripheral. This is the most important information that you might have in your development. We also have the advice that we have a hardware C header that creates also an abstraction of the hardware memory with macros. Like this one is define SPI buffer base with the specific memory allocation. We have two communications here. And, the first one is pooling. It's called pooling. That means that the projector periodically checks whether the task has been complete. Pooling is within a loop, which is reading the status of a function all the time. Interrupts is an asynchronous electrical signal from external and internal peripherals. Interrupts are dispatched by the ISR, and the ISR acronym stands for Interrupt Service Routine. This means that the processor that has interrupts after the processing of the current work set aside the current work before the processor returns to the work that has interrupt. Set the interruption, and it determines which one to select. So the interrupt has the advantage of being more efficient in the use of the processor than the pooling. The processor can use the idle time for interruptions. Pooling is typically used when the processor must respond on events as faster as possible. Next slide is if you're going to use only high-level approaches, then almost all the processors behave the same. But if you are going to do any assembly, you need to do any assembly languages programming, then you need to be familiarized yourself with the processor register architecture and the instruction set. You also want to understand the data books, like this example, of the processor. Usually they are well grounded and they are the ideal place to start. In the case of the Raspberry Pi 2, you will reach the VCM2836 databook. Also, you should respond questions regarding how the processor handles interrupts, the address from where the processor resets, the interrupt vector table, and so on. We have also the topic of development boards. We have some benefits that usually the development boards helps you to understand peripheral functionality. Also, the boards typically include software examples that can get you up in the learning curve of a lot faster. Another benefit of the development boards is to have regression testing. This means that if you are having some ODs in the environment, you can go back to the development board and supposedly that the hardware is stable there and debug the application. Next slide is external peripherals. Peripherals are any hardware device that is outside the processor. Peripherals also has the task of communicate with the processor by interrupts and input-output memory mapped registers. There are some examples: the LCDs, the analog to digital converter, network interface, and so on. About device drivers is that a device driver is a collection of software routines that insulates the software and operations of a specific hardware device. We have a diagram here that is called initializing the hardware and the software of the microprocessor. So, microcontroller. So some microcontrollers require the code to initialize their hardware at the startup. Usually this process is running in assembly. These three steps they are running in assembly. So the initialization should be executed before the start of code. The first one is the reset that just transfers the control to the hardware initialization. Checks that the processor, you might check that the processor data book, where is the reset address to place the first instruction on the reset. The next step is the hardware initialization, and this informs the processor about its environment and places the critical peripheral initialization controller. Also, there are some processors that program the registers to wake up each of the memory and peripheral devices that are connected to the processor. Moreover, some processors have chip selection. And the last point is that there is also some processors that have chip selection with accesses the different memories range from other chips that are connected in the processor. And at the end of the hardware initialization, the entire range of ROM and RAM memory are available to be accessed from the remaining software. The last one is the startup code. And it prepares how to interpret the high-level language and set up the stack. By the way, the stack is an area of the RAM for temporary storage during the execution. The last slide is regarding about troubleshoot for initialization issues. The first one is that you need to make sure that the processor and the RAM are receiving the required voltage. The second is that you need to check the clock signal is running. The third one is you need to check that the processor is coming out of reset properly. Next one is check that the watchdog is in resetting the processor, and the last one is to make sure that the interrupt pins are pulled down high. So that's it.